let's talk about a revolutionary new way to hunt for bugs in the software we all rely on. It's a technique so clever, it's basically like giving security researchers a save game button for their work. Seriously, let's dive in. So first, just think about the challenge here. How do you possibly test something that's designed to never turn off? I'm talking about the web servers that deliver your favorite sites, or even the browser you're using right this second. They're always on, always processing data. Finding one tiny weak spot in these massive, super complex systems is a pretty monumental task. And this right here, this is what we call the bug hunter's dilemma. For years, their number one weapon in this fight has been a technique called fuzz testing, or, fuzzing. The idea is actually simple, but it's really powerful. You just bombard a program with junk data, millions of slightly broken files or weird network packets, and you just wait for something to crash. It's an incredibly effective, automated way to find those hidden vulnerabilities. But, and there's always a but, right? Here's the problem. Well, fuzzing is absolutely great for simple programs. It just hits a brick wall when you try to use it on the most important software out there. The stuff that basically runs the internet. It turns into a total network nightmare. And the reason why is, well, it's pretty fundamental. A simple program is easy, right? You feed it a file, it runs, it stops. You can do that thousands of times a second. But network software, that's a completely different beast. It's stateful, which is a fancy way of saying it remembers what happened before. You can't just restart it for every single test. Just the startup process alone takes way, way too long. Because of this, the older tools like AFLnet were just painful to use. Network connections are super slow, which totally kills your testing speed. And even worse, the state from one test could bleed over into the next one, creating all this noise and making the results totally unreliable. Researchers had to write these complicated manual scripts just to clean everything up between runs. And even then, they were basically just guessing with timers, hoping the server was ready for the next test. So the big takeaway here is this. The very software that needed the most intense security testing was also the hardest to test effectively. The tools just weren't up to the job. It was clear that a completely new approach was desperately needed. And that solution begins with a new system called Nyx-Net, which started with a radically simple but brilliant idea. What if, instead of dealing with all those slow reboots and clunky manual cleanup scripts, you could take a perfect picture of the system right before a test starts, and then, after the test, instantly snap right back to that perfect picture? This is the core idea of hypervisor-based snapshot fuzzing. You let that complex server start up just one time. Then you take a snapshot of the entire system's memory and state. You run your one little test, and then boom, in a fraction of a second, you restore that pristine snapshot. You can do this thousands of times every second. And the benefit here is just enormous. Every single test is perfectly isolated. There's zero noise, no leftover state from a previous run, no contamination whatsoever. You get clean, reliable, and incredibly fast results. I mean, this alone is a massive leap forward. But that's just the beginning. The real genius of Nyx-Net is an even more clever enhancement that they built right on top of this. Think about it. What if a program needs a really complex, multi-step handshake before you can even get to the interesting part you want to test? If you reset all the way to the beginning every single time, you're wasting thousands of cycles just replaying that same boring handshake over and over and over. And this is it. This is the save game moment. And honestly, this Super Mario visual is perfect. Imagine the red path is the fuzzer, just playing through the easy, repetitive part of the level. Then, right before a super difficult jump, it creates a save point. From there, it can try thousands of different ways to make that jump. Those are the green paths. Instantly resetting to that save point every single time, without ever having to replay all those boring parts of the level again. So the technical term for this save point is incremental snapshots. It's the ability to create these cheap, temporary snapshots deep inside a really complex test case. This lets the fuzzer focus all of its power exactly where it matters the most, which just dramatically boosts its efficiency. Okay, so this all sounds amazing in theory, right? But does it actually work in practice? Well, the results are, frankly, stunning. First up, speed. Compared to the previous state-of-the-art tools, Nyx-Net can be up to 300 times faster. Now, that's not just a small improvement. That is a generational leap. It's a whole new ballgame. And with all that speed, you get depth. More tests means you can explore more of the software. In their experiments, the researchers saw up to 70% more code coverage. That means Nyx-Net was finding and testing parts of the code that other fuzzers just couldn't even reach. And look, these aren't just some numbers in an academic paper. This power translated directly into finding real, honest-to-goodness zero-day vulnerabilities in critical software that is widely used. I mean, for example, Nyx-Net found brand new bugs in the Lighttpd web server, the client for MySQL, which is the world's most popular database, and even deep inside the really complex communication channels of the Firefox browser. The impact was so huge that Mozilla's own security team publicly stated that Nyx-Net's approach, quote, solves a long-standing problem they had been struggling with for years. I mean, that is a powerful endorsement. And it wasn't just praise. Mozilla awarded the research team a $20,000 bug bounty, not just for the bugs themselves, but for creating a tool that unlocked a whole new level of security testing for Firefox. It really all comes back to that simple, brilliant idea. By giving bug hunters a save game button, Nyx-Net has made testing some of our most complex and critical software faster, deeper, and more effective than ever before. And it really leaves you wondering what other seemingly impossible problems out there could be solved with a magic reset button.